Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Defaikal Bermuadri. Today I would like to explain about introduction. This research focuses on the one rotor motor, a version of the three-phase induction motor which provides steady and high starting torque for load. This motor has great inertia and requires little current. This type of induction motor connects to the rotor winding and slip ring. The winding rotor motor operates similarly to conventional induction motor but include additional tools such as brushes and slip ring. Slip ring link rotor's winding to external resistance. Slip is the difference between synchronous and real speed. As the load grows, the motor slows down and generates additional torque to compensate. Induction motor has dropping working area due to their torque speed and characteristics. In this research, a table of parameters of each value has been made based on the instruction to do the analysis about the torque speed characteristic and power speed characteristic. For the first parameter, its V phase is equal to 480. Number of pole is 8. Rated HP is 50. R1 is equal to 0.2. S1 is 0.4. R2 is 0.5. S2 is 1.4. SM is 50. The mechanical losses is 400. Core losses is 300 and miscellaneous losses is 0.2. The following parameters are given to represent a 50 Hz wire connected three-phase induction motor. For torque speed characteristic, pull-out torque can be found based on the calculation. Maximum converted power can be obtained from the power speed characteristic calculation. Then the overall efficiency can be obtained to see if the induction motor was good or not. In conclusion, the large load caused the motor to operate in high slip mode, resulting in lower speed. This study examined how the load affected motor operation. The simulation system will reveal difference in efficiency and major attribute. The machine will be evaluated using different load parameters.
Hi, my name is Muhammad Ashraf bin Kamar Zaman. My matrix number CE230154. Today, I would like to present about the manual calculation of our project, which is induction motor. So the value of the parameter that we select in our project is the first one is frequency. So the frequency is 50 Hz and the rated voltage 480 volt, pole 8, rated horsepower 50, R1 0.2 ohm, X1 0.4 ohm, R2 0.5 ohm, X2 1.4 ohm, XM 50 ohm, power mechanical loss 400 watts, power core loss 300 watts, power miscellaneous loss is 0.2, and the slip that we focus is 0.05, and this is our circuit that we conclude from our project. So the step one, to find the torque, we need find the N sync, which is the formula is 120 multiply frequency over pole, and we get 750 RPM. Next step is we find X Thevenin, which is the formula S1 parallel with SM, and we get the answer 0.397. The next step, R Thevenin, which is R1 parallel with SM, and we get 0.199. And next step is we find V phase, which is 400 divide square root 3, and 1134. After that, we need to find the center, which is up to the split price function times 2, and we get the answer in the tabular form, which is 10 plus 1.44. Other than that, we need to find the ZF, which is XF parallel with Z2, and we get answer the answer is like the tabular form, 1118, which is the RF value plus T3.136 for XF, and we need to find the IF for calculating the torque. Next step is we need to find the power and cap for calculating the torque. So the formula is 3 multiply with IL, the power of 2, multiply with RF. The value of RF is we get from ZF, which is 9.118, and we get the answer 21,153.96 watts, and we need to find the torque. And other than that, to find the power, we can put the form equal to power, and we need to find the power also using the square function and phase IL and cos theta, and we get the 21,660.11 watts, and we calculate the power output, which is power converted, power mechanical power minus mechanical losses, and power for loss, power basically against, and we get the answer 80,696.06 watts, and plus we need to find the efficiency, which is power output over power input, multiply with 100, and we get 9.73%.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Akim Zaframir Romzi. My nomenclature CE230121, and today I want to present a result and discussion. Result and discussion. We have to create an Excel file to solve the mathematical equation that we need to calculate for the project by using the Excel software, by putting the program into it to generate the solution for us. We need to determine the value of parameter for our envelope according to the range of parameter that has been given the instruction for the rated voltage, number of poles, rated horsepower, the impedance, the mechanical loss, core loss, and also the miscellaneous loss. Second, we need to create an induction motor model in the Excel and calculate the value for the induction motor in the Excel with our setup of parameter that we choose to use by referring the formula from the lecture notes and key in all the data, the parameter that can be used to generate the value that we want by using the Excel. It can generate the answer for the calculation for the induction motor model using the program, and to make the confirmation of the parameter, we make a double check by using the manual calculation. Lastly, after setting the calculation of the parameter for the table, we need from the table of value we have to generate the line graph show the torque speed characteristic and also for the power speed characteristic graph. The graph can be generated by calculation that we have done calculate it by Alright, first we choose our parameter 480 volt, 8 poles, 50 rated horsepower, and 0.2, 0.4, 0.5, 144, and 50 value for the impedance, 400 for the mechanical loss, 300 for core loss, and last but not least is 0.2 for miscellaneous loss. Okay, this is the top speed characteristic we got. The top speed characteristic of the electric motor shown in a graph of torque versus speed is key to understanding the performance. Initially from 0 to about 1200 rpm, torque increase steadily, indicating strong starting torque. Alright, so we can look from the graph. The result one is the induction torque versus motor speed graph illustrate the operation of an induction motor at about 1315 rpm, the graph maximum torque, and 49.95 Nm torque. This is the power speed of the characteristic. So an induction motor power speed characteristic curve is essential for understanding its performance and efficiency. So this graph which plots motor speed against power output, level power increase with speed up to a peak. So the result, the power versus speed graph illustrate the operation of an induction motor. The speed increase, the power first rises and reach a maximum value. So we can look from the graph. Alright, so that's all from me. Thank you.